Hello everybody. I'm going to start this video off with a kind of brief introduction to who I am and what these videos and this channel kind of hopes to accomplish. So first off, I am Brandon. I've worked in the games industry professionally now for 2 years, but I've been messing with VFX and learning the craft for probably like 5 years now. I've worked on a game called Wildflowers, which was really fun. I did all the VFX for that, and I'm currently working with Shiny Shoe full-time on our game called Inkbound that will be coming out in early access in just a few months, May 22nd. The goals of this set of videos is to get people who are interested in learning VFX, specifically with Unity, but this knowledge applies all over the place. It's pretty easy to pick up another engine after you've learned one, but I want to get people who are interested in VFX up to speed with kind of the basics in Unity and give people tools and resources that I wish I would have had as I was learning, because I feel like a lot of the information in VFX and related fields is kind of hard to come by specific information. So I just want to get people who are interested up to speed as quickly as I can and actually making effects. I'll warn you ahead of time, I will be making a lot of cuts in this video because I cannot hold a train of thought for more than 15 seconds, and my cats are always jumping on me as I talk. So if you hear cuts in the audio, that is why. I'm either trying to rub my brain cells together to make a thought or throwing a cat off of my lap. So the first thing I'd like to cover is just the general kind of Unity view. I'm not going to get super into Unity because there are a lot of great guides out there on getting started with the engine as a whole. I'll see if I can link one in the description. But the very basics, this is your scene view. This is where you're going to be doing your, actual work in the scene. And this is the game view. This basically grabs your main camera or whatever camera is currently active and shows you what it's seeing. If you run the game, then you'll be seeing what the camera sees, and all of your scripts and everything will be executed and the game will be running. Basically, this is a little bite-sized way to run your game without building it. This over to the left-hand side is your hierarchy. This basically just shows you everything that's currently in your scene. If you press the little plus here, you can add things to your scene. If you right-click, you can also do the same. So that's about as far as I'm going to go into just kind of basic Unity stuff. Feel free to look up some extra videos on that and go in depth on, the different windows and tools you have available. Okay, so let's jump into some actual VFX stuff here. So the crux, the basic foothold of VFX is the particle system. So if you go up to the plus here, go down to effects, you can add in a particle system. Here it is. Boom, you got some great VFX right here. So what a particle system does right out the gates is slaps down this emitter, and the emitter is shooting out billboards. Billboards are basically quads or planes that are always facing the camera, and these have some default Unity material assigned to them here that has the default particle hooked up to them, and it's transparent material. So I'm just going to go through some of the modules here in the particle system that are super beneficial to know about and are kind of the basics of how you actually make effects. So particle systems are used for a lot of different things. They kind of replace the need for having to hand key and move things in an animation, which I'll still do sometimes if it's like mesh based and I really want to get hands on with the timing and everything and be able to move the keyframes around. But for like getting organic movement and little things flying around, particle systems are great, and they're also great for just spawning kind of static things or like one-off elements in your effects. Most effects are going to be comprised of multiple particle systems, sometimes even triggering particle systems to be turned on and off with an animation clip as well. So I'm going to go through some of the modules here and actually show you what it does and the power that it actually has. Okay, so the inspector window over here shows us the particle system that we currently have selected. The inspector is what shows you anything you currently have selected and will show you information about it and values you can adjust. So here in the particle system, we have at the very top, this is kind of the main defining features of your particle system. You know, duration, does it loop, delay it if you turn it on, things like that. So I'm going to go through each of these. Duration basically defines how long until it loops. Here's a nice descriptor right there. So yeah, if you hover over these, they'll give you more information if you're curious about them. But yeah, if it's not looping, this is how long it's going to play. So if I set this to 1 second, this is going to emit the particles for only 1 second, and then it's done. If it is set to loop, that'll be how long per cycle it is, which cycles aren't that important unless you're doing bursts and things like that. But in general, yeah, if you want looping effects, turn on the looping. If you don't turn it off. Pre-warm is, I'll show you. So you see how it's starting to emit them from the base as soon as I hit restart on this? That's because it's not pre-warmed. If it is pre-warmed, it'll kind of give you a seed as if it was already emitting. This is nice for like environment stuff where if the player loads into the scene, you don't really want them to see all this stuff starting. You want it to seem like it's already been running as they were gone. So that's what pre-warm does. Like I said, useful for environment stuff. Here we have start delay. So if you're not pre-warming, you can choose a start delay. So this is in seconds. All this stuff's in seconds. So if I am delaying this by a second, when I restart it, or when this is created in the scene by whatever means you're doing it, it will delay it. Turning on here, you can see a timer by 1 second. This is handy when you're layering a bunch of effects on top of each other and you don't want to do like an animation clip to control all the different particle systems. You could set delays and have stuff fire off just like as it should right when you spawn the object. Lifetime is how long each particle is living in seconds. So these are currently lasting 5 seconds. So if I scroll my mouse wheel here in the scene view, you can hold Alt and the middle mouse button to pan. You can see they're living a very long time. If you hold Alt and left click, you'll be able to rotate your view. They're living a long time, 5 seconds. That's pretty long in VFX terms. But if you change this to 1 second, you'll see they start popping out way sooner. So that one's pretty easy, but it's also, lifetime is the information that a lot of other modules will end up using later. Once we get down here, you'll see what I mean. Speed is how fast the particles are moving. Pretty easy to understand there. From your emitter in the direction that your emitter is facing, or depending on the type of emitter you're using, they could be flying out in all directions or just straight. The shape of a basic particle emitter when you spawn it is a cone. So these are all flying upwards in a cone. So yeah, speed controls how fast they move. Size, also pretty self-explanatory, controls how big they are. And you can split this into 3 axes by checking this box. You can make them longer on the X, skinnier, longer on the Y. Z as well, but that's not going to matter much to us right now because we're using billboards, and billboards don't really have a Z-axis like that as far as scaling goes. So if you had a mesh or something you were emitting, then that would matter, but right now that does not concern us. And another good thing to note right away is that these little drop downs will give you more options over on the right hand side. So for size, what I do for a lot of effects all the time is random between 2 constants, and what this will do is give you 2 floats you can choose, and it will do random numbers between these 2. So this is not 1 or 2, it's 1 and 2 and filling out everything between. So this is not a fixed value. You're getting some things that are going to be 1.2, 1.3, whatever. So you're just feeding it a range of sizes, and this works for a ton of different modules in the particle system. Start rotation is going to allow us to choose a angle for each particle spawning. If we do split the sizes here, I'll be able to actually show you the rotation. So if they're long like this on the X, then it'll be easier for you to see the rotation. So if I start them at a 90-degree rotation, then they'll be straight up. And this is moving the actual plane. This is not moving the texture. That's kind of important to note. So your UVs and everything are going to rotate with the plane itself that's facing the camera. Flip rotation is just basically going to give you a amount of particles. So if I do 0.5, it's going to be half the particles that are going to be flipped in the other direction. Kind of hard to see here, but this will like flip the texture. So if you have, a texture that's distinct on either side, it's nice to flip some of them to add a more organic look to your effect. This is start color, which is very handy, and we'll go into it more later, but this is basically multiplying your texture by a vertex color. So it's got a great color wheel, lots of options, plenty of things you can do here. Dark particles, alpha. Alpha works with the basic particle system, or the basic particle shader. Yeah, so alpha's down here. This will basically make your things more transparent. And this is your color wheel, color picker here, where you can go and find whatever color best suits the effect for you. Gravity, very fun, very useful. Basically does exactly what you would think it does. If you increase the value, it will take gravity into effect and start dropping your particles off. After, I believe gravity kind of works on a curve. You see how it's like falling quicker as it starts moving downwards. And cool thing about gravity is you can also invert it. You can do negative gravity. I do that fairly often to keep things kind of organically, like their speed kind of curves upwards as they fly up. It's nice to use. Simulation space, local, world, and custom. I don't know much about custom simulation spaces, but local basically means if I move this, it's going to stick to that emitter, or it's going to stick to whatever parent object there is. So this just means keep things local, local being in this space of this object or the parent object. Now if I do world, that's going to allow it to leave the particles behind. There are plenty of cases to use both world and local space, so I'll let you figure that one out. Simulation speed, basically this is set to 1 by default, and that's saying play your simulation back at 100% speed. So if I double it to 2, that's playing it at 200% speed. I find this really useful if I'm close to the timing I want, or say my art director is talking to me and he's like, can you reduce that speed by 30%? Well, then I can just, or the overall simulation by 30%, then I can just do 0.7, and we're at 70% simulation speed now. So it's nice for making like broad stroke adjustments to the whole thing instead of like going in and fiddling around with the lifetime and stuff like that. Delta time basically is like, delta time is the internal kind of clock of your game. So this basically, if you set it to scaled, it's going to be running in tandem with your internal clock, basically, of your engine. And if you set it to unscaled, it will run kind of on its own time, so you can play effects while it's paused, or while your game's paused and things like that. Scaling mode, I'm not so sure about shape. I've never used that, and you probably won't either. When it's set to local, this will just scale by itself. So if I press R here, it's the hotkey for switching to scaling mode. If I stretch it upwards, it's going to stretch up, down, whatever, left, right. And this is all in local space. This is only affecting this object. But if I set it to hierarchy, which most of the time your particle systems and everything are going to be parented to something else. So if I set it to hierarchy and I right click and I create an empty game object, we'll just set this to 0 on all the transforms. We'll do the same for the particle system, and I drag it onto this one to parent it. Now this particle system is a child of this empty object. Now if I scale this parent object, it's going to scale what's underneath. If I change this back to local, it will not. It will keep that same scale. That's kind of weird that it's flipping it, but yes, it's not going to stretch upwards as I move the y-axis up on the scale. So if you have a parent object and you want to be able to scale the whole effect, if it's just a little bit too small, it's nice to set everything to hierarchy. That way you can just increase the size of everything all at once, and you'll probably have to go in and make little adjustments to some stuff to keep it the same size, but it's nice to be able to go in and adjust the entire scale of the whole thing and all the child objects. Max particles can definitely be useful. This is just the maximum amount of particles that are allowed to be in existence with this particle system. So if I set it to 1, only 1 is allowed to be alive at a time. And I believe, I don't know if the youngest will replace. It looks like the youngest does not replace it, so basically it'll keep the oldest one alive, and then once that one dies, it then replaces it with the next one. So it's useful for, I don't know, if you want a high emission rate, but you only want one on screen at a time, then I guess it's nice. I don't use it that often. Auto random seed basically says every time that this thing plays itself, give it a random seed. I sometimes will do a manual seed. So now if you see, it's going to start the same every time since I turned that off. And that's because you have a manual seed here, and then you can reseed it to give you a random one, and it'll always start playing out the same way. And it'll play out the exact same way every time you do it. That's nice if you found a look you like. I've definitely done that before where I want it to look organic, but I don't really want it to look different every time. Then I'll manually seed it and just find a seed that I like that looks good, especially stuff for like player abilities. It's nice to have consistency there. So that's when I would do a manual seed, when you want something consistent, but you want to flip through those seeds and find a look that looks good, but you want to keep that look. Know what I'm saying? Yeah. Stop action basically says, hey, if your particle system's done playing, should you either turn it off or destroy it? Not sure what callback is. It might be turning it off and then turning it back on. But yeah, I don't really use this because the programmers who handle the tech side of spawning in the stuff normally have like a built-in way that they're killing off particle systems, but I guess this is a nice secondary way to do it. Okay, that's like the most important stuff up here. I'm not going to go through each and every little tiny thing if it's not insanely useful for this. I'm just trying to give you broad strokes right now and let you know important information about each of these things. So Emission is the next module. If you turn it off, it's not going to emit anything. Emission is what controls how many are being emitted and why they're being emitted. So rate over time is saying how many particles am I emitting per second. So this is 10 right now. They have a 1 second lifetime, so I'm emitting 10 per second, so there's always 10 on screen. So if I set this to 5, it's only emitting 5. Pretty self-explanatory. If you want to crank those numbers up, you're going to emit more particles. Now, a lot of the times I will want to do a rate over distance instead of a rate over time. So if I set this to world here, it's in the simulation space, and I set it to emit over distance, I don't know the exact baseline numbers here. It's per distance unit. I believe you can change that in Unity, so that doesn't really mean much, but per distant unit, it's going to emit 1 particle as it's moving, as long as it's active. So if I move it here, since it's in world space, it's leaving them behind. You can see it's emitting a bunch. There's a particle counter here on this. You can see how many are alive. It's about 30 when I do it like that, but this is based on, how many units you're covering. So it's like, this could be a lot. So if your thing's moving really fast and it covers a bunch of distance, it's going to emit more. So it's kind of touch and go. You have to dial it in if you're using this. A lot of the times games will create a like projectile object and move this game object through the space. And if you want stuff kind of falling off the back or trailing behind, this is how I would do it. And yeah, you just have to dial in based on the projectile speed of how many of these you really want to be emitting. Next up is bursts. So you have to add in bursts here with this little plus. This basically says every cycle you're going to emit 30 particles here. And another thing to note is, see this time is set to 0. So when I hit restart, if I don't have anything emitting and I'm only doing the bursts, it's looping here. So that's why every single cycle after 1 second, it's looping and shooting out another 30. If I don't set this to loop, then I have to manually do it. I'm hitting the restart button every time. But a nice thing about bursts is that it's not waiting 1 second for me to, or for the particle system to play. So if I didn't have this looping and I was emitting 1 particle over time, as soon as I click restart, this needs to last longer. This loop needs to last longer. Okay, so as soon as I hit restart, it does not instantly fire off a particle. Okay, it waits 1 second because I'm emitting a particle every second, 1 per second. So I would have to like really crank up that emission rate if I wanted particles to instantly start spewing out as soon as I hit this. This is where, you know, you can use the max particles, I guess, if you wanted to. If you only wanted one on screen, but you wanted to like have it instantly fire as soon as it was spawned, you could do it like that. But what I do most of the time is just do a burst. If I need something to come in instantly as soon as it's spawned, a burst is nice because that happens as soon as this object comes into the world. A burst. And then you can even follow it up with rate over time. So if I had 1 per second and a burst, it would shoot out 1 and then it would start shooting out the others. But then every cycle it's going to do that burst again, which I believe you can adjust how often it does that. These are your cycles here, how many times it emits the burst within that cycle. So you can adjust all that. Intervals is how many it waits, or how long it waits between the cycles. Probability is the chance that it will. So 1.0 is 100% chance that it's going to emit this burst. I can't say I've ever needed a burst to be a percentage chance that it wouldn't trigger, but I'm sure there are use cases out there, probably in environment art. You want random stuff to be shooting out occasionally. And time, this is just when it'll trigger. So if I set this to 10, then it's going to wait a second. And then if I set the count to 10, time to 1, it's going to wait 1 second. This is basically start delay for bursts. Okay, moving on to the shape module here. This video is already shaping up to be way longer than I thought it would be, but talking about each of these individual things is time consuming. So the shape basically defines the shape of your emitter and also the direction that your particles are going to be traveling based on your speed. So cones are shooting towards this opening. This is rotated. When you spawn in a particle system, it automatically has a negative 90-degree rotation. I don't know why, but if you set this to 0 up here, this is your transforms for your game objects, by the way. Position and rotation and scale. So I don't know why it spawns in at negative 90, but it does. So now this is normally what I want. If I want a cone, I want it to be facing the Z axis because this will be the front. This is positive Z. So this is the way the object is supposed to be looking. So shapes, the shape module defines this emitter and how it is shaped. So you see how these, I'm going to set this to loop and kind of increase the emission a little bit. I'm also going to set the size back down so we can actually see what's going on per particle. So if you see, they're following this kind of outline here. So this cone has controllable variables down here. The angle is how wide this angle is on the cone. If I wanted everything to kind of go straight, I would tighten that up to 0. But if I want it to fan out into a more of a cone shape, then you can adjust it there. And these all move forward from the base. And you can change where they emit from. I could make it emit from the whole thing, the volume. So it could emit from anywhere. I don't really do this often unless I need like a cylinder type shape for whatever reason to emit these from. And you can change this shape to whatever. So spheres I use a lot. Spheres emit things in all directions. So wherever a particle spawns, it's going to shoot outwards from where it spawned towards whatever. I don't know how it defines. It's probably like vertexes or something, but it shoots them out from the sphere out into the void in whatever direction they spawn facing. And you can also change the radius of this, which is handy. I often, if I have like a flash effect or something and I just really need it to spawn at the same exact point every time, then I would shrink it down. And the radius thickness defines how far in it will spawn. So if I set it to here, these particles are now only spawning in between these two shapes here. So this controls the space between where it can spawn. So if I set it all the way to 0, it can spawn anywhere in this shape. If I bring it back down, it will only spawn between these two outlines here. So that's handy if you want that. I mean, I've used it before for like especially cones. I tend to not want things to spawn directly in the center sometimes. I want it just on the rim. Same with circles. If I'm trying to match up the shape to something else, like say I'm doing this on top of a texture or something like that, a circular texture, then I can kind of match up. I can say only spawn on this rim because this texture is underneath here. So radius thickness and radius are super important for defining the actual shape and size of your emitter. Some of them have an arc you can control like this, so you could do like a semicircle. You can control the angle. So that's nice. Sometimes that's handy. I kind of rarely do that, but definitely nice for when you're trying to match stuff up over top of other things. So this is your emission mode. It basically says kind of the pattern you want your particles to spawn. So random is just going to throw them out randomly. It's going to pick a random point in this shape and just toss them in there. If I set it to loop, then it's going to pick a couple points and just loop between. Depending on your shape, this can function differently. Ping pong is going to go between the two. It's going to bounce back and forth and back and forth. As you can see here, if I increase the emission, it's going to this point, back and forth, bouncing. Useful sometimes. I don't use it that often. Loop is just kind of swirling all around. Burst spread is super handy. I use this very often. So as you can see here, it's not doing what you would expect. It's because you're not doing a burst. So when you're doing regular emission, it's just going to throw it out of a single point. But if I do a burst of multiple, then it's going to try its hardest to spread these particles out evenly. So you get a nice clean shape when you emit them all. And you can see the circle's kind of broken up here. It's because we have this radius thickness is a little different because some of these are spawning closer to the center and some are spawning farther. But if I tightened this up all the way, it would give me a perfect circle because they're spreading themselves out evenly. So burst spread is super handy for when you're actually doing bursts and you want a nice clean look, or if you just want to, even if it wasn't clean, you just want to make sure you're not spawning a bunch of particles on top of each other and wasting those particles basically, because if they're spawning on top of each other, you're not going to see multiple. Your spread down here is kind of defining the angle at which you're going to spawn the particles. I don't use spread. If I needed to define the arc, I would just adjust it here, which is like kind of the same exact thing. Well, I guess it's a little different because then you can still have the full shape, but I don't really use spread for anything. Position, rotation, scale here will specifically let you kind of offset the emitter from the actual game object, which can be useful. So if you want to scale down this circle into like an oval, then it's going to be different than doing it up here, because this is actually going to scale your particles as well. And if you just want to get the right shape, I do this pretty often for cones, because a lot of times you want like a squished cone. If you're doing like a cone based player attack, you don't want it to be like a full 360 cone. You want it to be kind of squished like an oval. So that will let you maintain your particles form for each one, but let you mess around with the actual emitter scale, which is super helpful. Align to direction basically faces your particles the way they're moving, which can be useful. I don't use it that often, but if for whatever reason you wanted your particles to face on the z-axis towards the direction they're moving, then that's the setting for you. Randomized direction basically decides to throw your particles in a random direction. Super simple. So it's going to kind of override their initial trajectory, and instead of following the speed and shape of your emitter, they're just going to throw them randomly. So I guess I could see that being useful. I also don't use that one very much. I like to have more control over where stuff's going, but if you just want to throw stuff around randomly, there you go. Spherize, if you're not using a shape like a circle or a sphere already, then it will, if you set this to 1, it will move everything from the center of the particle system outwards in all directions as if it was a sphere emitter. And randomize will just randomize the starting position of your particles. Okay, velocity over lifetime. This is some fun stuff. I like to use this all the time. So this is kind of another override. Not necessarily an override, but it's just influencing your particles extra. So if I set this to loop, I'm going to go ahead and just make particles come out over time, randomly, and looping. Okay, so this says linearly over the lifetime of the particle, I can move it along an axis. So this is how you can kind of use different shape modules regardless of where they kind of shoot their particles naturally based on the speed parameter up here. So if I turned off speed altogether and I just let velocity over lifetime take over, if you notice it's not shooting them outwards anymore. I'm choosing the axis that I want these to follow. Super handy. I use it often. You can use this instead of gravity if you want things to just move upwards. And you can do multiple at the same time. So I can say go out and up. And there you go. Same with X. Out and up and left. So I love velocity over lifetime. It's very handy. And of course, if you have no speed, no velocity, stuff doesn't move. It just stays in place. An orbital is very fun. So if I rotate this, and I want this to be orbital on the Y, so over the lifetime, it's going to orbit the Y-axis. Press Q, by the way, if you want to hide your gizmo. And if you close your shape module, you won't see the shape outline anymore. So this is great. It's a lot of fun. You can make stuff spin around real fast and orbit other effects, things like that. Works in the negative too, to go the other direction. You can make it orbit any axis you want, multiple axes. You can get some really cool results if you combine it with other effects. Offset just applies an offset from the center of the particle. So all these particles have a center pivot. So if you offset their rotation here, it basically just moves the center point at which they're rotating at, which could be useful. I don't know. Can't say I've ever used that. Okay, so I am going to skip over a few that I just never really use. I mean, limiting velocity over lifetime is kind of nice because you can basically dampen the speed over the lifetime, but I can't say I ever use it that much. Inherent velocity, I'd never use. Lifetime by emitter speed, I never used that in my life. Basically, it would increase the lifetime per particle based on how fast your emitter itself is moving, or decrease the lifetime based on a curve. Never use that, probably never will. Force over lifetime, similar to velocity over lifetime, but I believe this would use physics, so I never use that really. I don't do a lot of physics-based stuff with my particle systems. Occasionally I'll do collisions, but that's about it. Color over lifetime, okay, that's a big one. So color over lifetime allows us to change the vertex color of our particle over its lifetime. So see here, I can set a gradient. So basically, when it is born, it's orange, and by the time it is almost dead, it's going to be green. And you can adjust these keys to be closer to each other so that basically, when they pop into life, they're orange just for a minute, and then they switch to green, and then they're green the rest of the time. And you can add multiple different keys in here to give you a bunch of different colors over the lifetime, and that's super handy. And this is multiplied with your base color. So if you're doing color over lifetime, I would advise just leaving your start color white, because white will just allow this to take full control. But if I tried to blend in another color, as you can see, it gets all jacked up because it's trying to multiply these two colors together. So if you want to do color over lifetime exclusively, just leave your start color at white. Another very useful thing you can do with color over lifetime is set the alpha values, so you can have stuff fade out. So you can add more keys by clicking, just left click. So say I wanted this to both fade in and then out, I would add a key in the middle that was maxed out on the alpha, and then leave the two on the sides. And you can set the exact location here, so put this at 50%. So now stuff's fading in and out, which looks really nice. I'll cover that more later, but you basically always want your particles, or whatever you're doing in VFX, to have some sort of intro and some sort of outro. You don't want stuff popping in, unless it's something really fast-paced where it's you won't even notice it popped in because it just feels right. But most of the time, I would say you would want some sort of intro, some sort of outro, whether that be it growing or shrinking or fading out, or growing and then fading out. You can combine these different modules here to get those results. Color by speed, this will give you a gradient, and you can choose the speed range here between its full speed value and not moving at all, and change the color based on its speed. I never do that. Don't ever see a reason to. Size over lifetime, now this I use very often. So let's say, like I was talking before, we want this to grow. So if I turn this off, these are popping in and then fading out, right? But if I want them to grow and then fade out, I can turn that on. And that's another way to do an intro to a particle, is growing it in. I like to use this. I'm not sure if this is ease in, I believe. This is the curve I use all the time because it just looks nice organically. It kind of puffs up a little faster and then slowly reaches its max size, and then you can allow it to fade out. Good for smoke and stuff like that. And you can change your curves down here. They have a lot of presets. And you can also make your own curve. Another one I do often is this one. I have it saved as a preset for my own uses, is up down. And if you make your own curve, you can click the cog down here and click new, and it's going to save your new curve as a preset. So if I turned off my fade out, then you can see they're growing and shrinking, which is super handy, especially for blobby type stuff, or flashes that you want to grow and shrink instead of fade out. Very handy, love it, use size over lifetime all the time. Size by speed, same boat as color by speed. I never do that. I don't know why I would. Rotation over lifetime. Now this one is very useful. So as opposed to start rotation, which we had set to 90 earlier when we were screwing around, rotation over lifetime is going to actually rotate it throughout its lifetime. So if I want this whole thing to do a full 360 before it dies, that's what we want. We use rotation over lifetime. And remember, this is rotating your actual plane. This is not rotating the texture. This is important for very finely textured things where you can easily spot patterns in the textures. There's different ways to do rotations where you rotate the texture itself, which I'll show you at some point in the future with your shaders. But this is pretty suitable most of the time if you're just wanting a little bit of organic movement. And of course, you can randomize it between two constants. And so this, since this is a camera-facing particle, we don't really need to separate the axes because we know it's always facing us. So that's what it's assuming here. So this is 45 degrees to 360 degrees on, I guess this would be rotating it on the z-axis because the z-axis is facing us. Now, if this was a mesh and had, 3 dimensions and wasn't always facing our camera, we could break this into separate axes and say, okay, only rotate on the Y or whatever you want. So, very useful. I also use that all the time. So, rotation by speed is something that you would probably assume I would say I don't ever use, but I definitely do. But this is primarily used for if I have something colliding with the ground. So if it's like a burst of rocks or something that I want to kind of rotate through the air, and then as it hits the ground, I set the collision to make it lose all of its speed, and then I want it to stop rotating once it hits the ground. Obviously, it took me a while to figure this one out because for some reason it sets it to a constant, and I don't know why. It should just be a curve like everything else for the by speed stuff. So then you could choose, okay, if it is at 0 speed, set the rotation to nothing. And you kind of have to play with this a little bit. You have to push it forward sometimes to set the cutoff. But you just have to mess with it a little bit, and then you can get things to stop rotating if their speed is 0. External forces, wind zones, basically. I've never used a wind zone in my life, so I don't use that. Noise is more useful. I don't know. It's less useful, actually, than you would assume it is. It's kind of nice. Basically, it jumbles up your speed and direction based on like a noise map, and you can change the strength of it to really start jumbling up your stuff. As you can see, it gets sharper here, and then if you loosen up the strength, then it's not going to be as strong, and it's not going to be throwing your particles around as much. I don't know. I used to use this quite a bit for like embers and stuff to get like fully organic movement, but I kind of just use stuff like orbital velocities and things like that now. I don't use noise that much, but it can be nice, especially since it can scroll. So if you set a scroll speed, then it will scroll that noise map and make your particles do a little dance. I don't know. It's useful sometimes, but basically strength defines how hard your particles are getting yanked around. Frequency determines the scale of this noise map. So if I have a really big noise map, then it's going to just like jumble it around like it's basically static electricity, because that's what this looks like. It's static. It's basically following that kind of pattern. But if you have it smaller, then you're going to get bigger gaps in movement and not have stuff be jumbled up so tightly. And you can have multiple octaves. I think this basically, this just layers multiple noise maps on top of each other. I don't know. I don't really use it. Overall, I don't think it's very good on performance either to use this. I could be wrong there, but I don't know. I just avoid it. I get my random rotation values and stuff with speed out of this most of the time, the velocity over lifetime. Okay, so I've set us up a little scene here with a plane below the particle system so I can show you what the collision module does. So if I turn on collision, you can see it's showing me a radius around these particles. So if you want the collision to happen, later, halfway through the particle's texture or whatever, you would want to shrink this scale down. So it's like that. So collision is basically doing different things based on if it hits something. So you can set it to planes here and set up kind of specific planes in your scenes that this is allowed to interact with, or you can set this to world and you can choose the what does it collide with here. If it's everything, it's going to collide with everything on these layers, whatever. If you say nothing, and then you can pick the layers individually, say only collide with things on the default layer. That's what I do most of the time because our game has our terrain in a specific layer, so I normally just have stuff collide with terrain. That way it's not hitting characters or like set pieces or anything like that. I kind of just want things to hit the ground most of the time, so I normally have my ground objects on a specific layer. And in order for something to collide, it does need to have a collider. So when you create a plane up here like this, plus 3D object plane, those come pre-equipped with a mesh collider, so those will work for collisions. If you want it to collide with something, it's got to have a collider on it, because it's all physics-based. Okay, so if I set the gravity here to like 2, you'll see they're hitting and they're bouncing. Turn off my size over lifetime so you can see what's going on here. If I collapse this, it's going to hide the radius thing as well, so you can see what's going on. So these are bouncing because the bounce is turned up. When a particle collides, the bounce is scaled with this value. So basically, if you want your stuff to bounce a little bit when it hits the ground, which is nice for like debris and rubble and stuff, you just set this value. I probably wouldn't set it that high. It would be something like, sure, 0.3. That's not so bad. What I use most of the time is dampen. If I want things to just like stop moving altogether when it hits the ground, that's what I'll use. So if you set the dampen really high, it'll do that. Basically, dampen says, how much of my speed am I losing when I hit the ground? So if I set this to like 0.5, it'll lose half of its speed when it hits the ground. So it bounces just a little bit. And if it was moving, these particles were shooting in a direction, they would kind of skitter a little tiny bit. So basically, you just eyeball the dampen and decide how much speed you want it to lose when it collides with something. Lifetime loss I use often too, because if I want to trigger something on the particle's death and I want that death to occur when it collides, I would just set this to 1. That way this particle is getting killed as soon as it hits this. And that will lead into our next module down here, which is sub-emitters, which I'll have to set up a test case real quick for that. Okay, let's do that. Let's go ahead and set up another particle system. This one's, sure, we'll set it with a little bit of gravity. We'll make it burst 6 particles, none over time. We don't want it to loop. Sure, 1 second's fine, all that's fine. Let's set the speed to like 10. Test it. Okay, good enough. We'll turn off collision on those ones. I basically hit Control D here and just duplicated our particle system. So if you ever need to duplicate, Control D. So what you can do with sub-emitters down here, if I turn this on, I can say when this particle system, the parent one, does something, whether the particles are born or they collide with something or they die, whatever, I can make them do something. So let's say when these particles die, I want to trigger this particle system off of that one. And this is per particle. So each particle system that dies here is going to trigger this child. And it has to be a child of this. So when you create the new particle system you want to have as a sub-emitter, you need to make sure you parent this one. You want this to be a child of the one that's creating this sub-emitter here. So I basically slot in the sub-emitter. You can inherit stuff from the parent, so we can say, hey, inherit the color. So if I change the color of the parent here, if I turn back on my color over lifetime, then it should what happened. It should be inheriting that color. But I don't know why it's not. I don't know, Unity's weird sometimes, man. Well, it should be inheriting something. I don't know why it didn't want to inherit the color, but here we are. Most of the time I'm not wanting to inherit pretty much anything from the parent anyway. I want these sub-emitter systems to be their own thing, so I hardly inherit anything at all. But I do use this often when things collide with the ground and I kill them. I want a sub-emitter, say like a rocket hits the ground. I can have a sub-emitter spawn in after it hits the ground and spawn in some impact effects with it. So sub-emitters are useful. I use them pretty often. It's also nice to be able to emit them on birth of each particle. So basically each time a new particle is made, it fires off the emitter. So you can think of some interesting use cases for that. Okay, next up is the texture sheet animation. So this basically is flipbooks. So I can assign a material to this instead of this default particle. I'll go more into assigning materials later and creating new ones. But for now, I just want to show you. So if I create this is just a 2x2 texture sheet. Then it's going to show the whole thing. That looks silly. You don't want to do that. So if I turn on texture sheet animation, I can define the size of the sheet, which is 2x2, and it will change over time. So if I stop killing them on, well, we'll set this to no lifetime loss so they just pile up on the ground. Okay, as you can see, they are changing over the lifetime of the particle now, which is set here, time mode. And the frames over time, it's just got a nice linear curve here. It's just saying go through the whole sheet throughout the whole lifetime of the particle. This is nice for a lot of stuff. I use texture sheets occasionally. I try to avoid using a bunch of textures. I tend to work with like procedural stuff like noise and shape modules and things like that, but sometimes it's nice to be able to just throw a quick texture sheet together for stuff like lightning bolts and things like that. So basically you just define your size of your sheet here, and you can play it over the lifetime of the particle. Or I can say, hey, don't play it over the lifetime of the particle. Let's set this to random between two constants and just set it to 0. 0 is your first frame, and then 4 would be my last frame here because there's only 4 frames. Now it's going to pick a random particle off that sheet and spawn as that. So that's nice. I definitely have done that before. If you just want a random one off of your sheet, you can also set this to just a speed, or speed range. So this is going to be how fast the particle is moving. It'll start changing when it hits 0 because it's set to 0 to 1 right now. If I flip this 1 to 0, for some reason it's doing the same. Whatever, I don't really use that. But if I switch this to FPS, this is how many frames per second it's going to be changing. So it's nice to have manual control over the speed at which it's changing. If you want stuff to like loop, say you have like a butterfly tile sheet or something, you want to just constantly be cycling, you can just choose the speed manually and not have it be tied to the lifetime of the particle. And you can also choose your start frame here. If I wanted to start on 4 for whatever reason, I could. Okay, next up we have lights. I don't really use this because I don't think doing a bunch of active lights being spawned all the time by a particle system is very good on performance, so I just don't. But basically it kind of works like a sub-emitter where each time a particle spawns, go ahead and create a new point light here. Go to light in your right-click menu or your plus drop-down menu. You can create a point light, which just kind of shoots a light in all directions. It's like a sphere, basically. If you parent that to that particle system, because just like a sub-emitter, it needs to be parented, you can then slot it in right there, and each time this particle is created, it's going to spawn with a light. And you can also choose a ratio here, the amount of them that have the light source. So if I set this to 1, it's going to spawn with all of them, and it's also naturally inheriting the particle color here. If you didn't want it to do that, you could turn it off, and it would just be white, or use whatever color you wanted it to. So if I set that to orange, they should be orange now. So I mean, it looks cool. Like if you really want to be spawning a bunch of lights, I probably wouldn't do that. If I increase the range here, it didn't really do much. I think I have to do that in this module. Yeah, range multiplier. You can increase how far the range goes. I don't think this material up for the plane is very good at being reflective to light, but you can also adjust the intensity of each light and make them bright in your face. Most games and stuff will have baked lighting, so using a bunch of real-time lighting on top of that isn't advisable, so I don't use this very often. But if you're smart with it and you only spawn like a few, then I'll allow it. You get a pass. Okay, next up is trails. I'm going to turn off these lights and turn off this point light. Okay, so trails are very handy. I use those all the time. It's grabbing a default particle system particle when I activate it. So basically this is just drawing a trail behind each particle. So it's like actively creating geo behind the particle as it moves. And you can adjust the width here. I can make it really skinny. Or what's even more fun is that the width over trail here can be adjusted as a curve. So I can say, hey, get skinnier as you fall down. Or I can tell it to be skinny at the beginning for whatever reason and fat at the back. It's fun to use trails, but you got to be careful about what kind of trail texture you are putting on stuff if you want it to look good. Like I would probably never use the default particle as a trail. Ratio is how many are spawning basically. So if I say 0.5, only half the particles are going to spawn with a trail attached to them. Lifetime is how long this trail is living with the particle. So if I set this to 0.3, they're going to get drastically shorter, and they're basically going to snap and kind of follow it. So once it gets past that 0.3 mark, 0.3 of the lifetime, basically it's just a fraction of the lifetime your particle's alive. Once it gets past that mark, it's going to snap off from its beginning point basically, and then just follow the particle down. And then when they hit the ground, they're going to stretch down and kind of collapse with the particle. You can also change these to ribbons. I've never used ribbons in any sort of project, but they are cool. They basically connect to neighboring particles, and you can increase the amount of ribbons. I'm sure there's cool uses for this. I just haven't found one that I've needed to make, but it is pretty sweet. But if you just set it back to particles, this just basically creates a line of geo behind your particle. And the minimum vertex distance is, how far they can travel before it adds a new vertex. So it's going to be a little bit heavier on performance if you decrease the minimum, but it will look better as they are coming down. Let's add some rotation here so I can show you what I mean. So if I set these to rotate like this, okay, and let's increase the lifetime of the trail here so you can see. That's a pretty smooth looking curve as it's turning, and that's because we lowered this. But if this was set to like 1, you can see the jagged edges kind of come in because it's not creating enough new vertices to support it. I personally don't love Unity's trail system. I think it gets hung up on itself a lot, and it ends up looking jagged even though I feel like I'm doing everything right. So I know there are other custom trail solutions out there, but as far as the basic particle system goes, this is what you get. So I always set this to like 0.01 just to have nice smooth trails. You can have them die with particles, or you can have them finish out their lifetime on their own, which is nice. It gives them time, and they don't pop out of existence right when your particle dies. Setting them in world space basically does the same as setting a particle to world space. So if my particles were local and my trail was in world space, when I move this particle system, the trails are going to trail behind because they're being left behind in world space, just like if we were to set the particles themselves to leave behind in world space. So I like to do that if I'm making a projectile and I need trails, you know, I'll set the trails to world space and have them follow behind my main projectile or whatever. If I want to have trails spiraling behind it, anything like that. Texture mode, you can change it to be tiled, so it'll repeat and tile itself. Distribute per segment, repeat per segment. It's going to repeat a bunch of the same of that same particle texture. I use stretch most of the time because I make textures and stuff that are basically just already set up to be a trail using stretch, so I always keep stretch on. Color over lifetime, you can change this to be a gradient, and over the lifetime of the trail I can do just like the particles, I can have it fade out the further it goes back. I think this is actually inverted. This is weird. So if I wanted to fade out towards the tail, I think I would, yeah, I would do that at the beginning. So you can fade it out, you can move this key to where it's more towards the front. You can change the color towards the front to be more red or whatever. It's inheriting the colors here from our base system, but basically the same as a particle color over lifetime module here. So yeah, trails are great. I use them often. Color over lifetime, color over trail too. This is what I was actually thinking I was on. Color over lifetime is just going to change it over its actual lifetime. Color over trail is what's going to give us the ability to control it fading out from the back or the front, or changing the color of the front and the back individually. Definitely useful sometimes, but I like to set my stuff in my shader so I don't use this too much. Custom data we are going to go into later on. I don't know if we're going to get to it in this tutorial because this is already pretty long just talking about particle systems, but this is how you basically access some extra information from your engine or your shader or whatever. This is extra stuff that doesn't come built in basically to the particle system. We'll get to that later. You will use this often. Renderer. So this is telling us what exactly our particle system is spitting out. We are telling it right now to give us a billboard. That is our camera facing quad that has a texture on it. We can also do stretched billboards. I'm going to turn off trails here so our eyes can actually see what is going on. This basically gives us a long version of our particle, and that's based on speed. So if it's going a direction, it's going to kind of stretch itself behind in that direction it's moving, which is pretty useful for like sparks and things like that, but you have to set up your textures to work well with that. Another really lovely thing about this particle system is I can set it to emit meshes. So let's change our material here to not have any texture on it. So I can tell it, hey, spit me out some cubes. And it will. I can put whatever mesh I want in here, which is another big fundamental part of VFX, is using meshes with specific UV maps. But we will get into all that much later as well. But I can change this to capsules, spheres, whatever. And it's going to spit these out, which is lovely. I use meshes in particle systems all the time. This is where your material is set. You could drag your material in here, or you can just drag it on top of the particle system and it'll change it. But if you have your trails turned on, then it'll give you another material slot where you can slot in a separate trail material, so they don't have to share the same material, which is lovely because you can interweave different materials to make cool effects. Sorting mode, you can just tell it, if these are transparent objects, you can tell it, hey, do it by distance, and whatever's closest to the camera will sort in front. Or the oldest, whatever particle has been alive the longest, will sort in front of the other ones. Or I guess distance and depth seem like the same thing, but depth would basically be using the depth buffer of the camera to tell you which ones are going to be rendered over top. I kind of just leave this off most of the time, honestly. I don't. Sometimes if I notice the younger ones are sorting more in front of the older ones, I will switch it to oldest in front, just because I don't want the little tiny particles that are still growing to render in front of the ones that are already big. So that I will use occasionally. Sorting fudge, I use this all the time, and you will too. You can also set this on your materials. I don't know if the basic... Yes, it does allow you to set sorting priority. So, if these are transparent, let's say I have two materials here. If I make another object, like another cube, big cube, and make another one, bigger cube, and I set these to be different materials. I don't know which is which here. Which one? Okay, bigger cube is this red one, and smaller cube is, we'll say, green. I can tell it to sort itself above big cube. I can tell small cube that you can be seen through big cube over top if I change the sorting priority. Hopefully this works. Okay, it does. Sometimes sorting gets really janky, and I normally do it with custom shaders and materials, but it works. So I can always see little cube. Little cube's sharing a material with a particle system, so that's why we can see it through there too. But I can always see little cube through big cube now, because I said, hey, this is more important in the sorting. This is super useful for layering stuff, like if you're making a fireball out of meshes, you can have a hot kind of inner core that's smaller, but you can sort it above, so you can still see it through the outer shell. Sorting is very important too for just keeping your particle systems nice and orderly. If you have like a fire with smoke behind it, then you would be able to see the fire in front of the smoke if you tell it to be ordered that way. And the reason I showed it to you on the materials, because that's how I normally control sorting, but you can also control sorting in the particle system itself. That's what this is, sorting fudge. So if I have another one, we'll say it has red ball material. Let's set these both to 0 so they don't have a preference on which is sorted in front. They kind of clip into each other, and it looks a little funky sometimes. But if I set red ball particle system to sort higher, wait a minute. Okay, so these are basically similar. I was thinking that this was order and layer. But this is sorting fudge. Lower the number and most likely particles appear in front of other transparent objects, including particles. Okay, so this is just like, hey, I have a slight preference as to this appearing in front of other particles or not. But I prefer doing it definitively to where this always sorts in front of green ball. So I'm saying red ball is 1, green ball is 0. This does not sort in front of the red. You will always see the reds in front. Super useful for stuff like sparks, smoke, fire. You want to do it kind of by order of importance of what your eye is actually seeing. So that's sorting. What else do we have here in the renderer? Flip. This is for textures. So if you... This basically flips the normals. So if I were to say flip 0.5, this would flip the normals of half of these particles. You see how they're looking kind of funky? I use it sometimes just to get some variation. If I have a texture, then I can just say, hey, flip half these particles the other way. Pivot. So all these spheres have a pivot that is set in their dead center. This will be easier if I just turn off gravity and make it a tight circle where everything is all tightly compacted. Let's turn off red ball system. Okay, so the pivot, as you can see, the pivot is basically the handle. This is my emitter right here at the very center point. Pivot is this, basically this gizmo. The center of this gizmo is the pivot. I can adjust the pivot of each particle individually. I can say, hey, the pivot's actually up here, or it's down lower, or it's left, or it's right. You can move that pivot point around. It works better, I believe, if it's in... Yeah, it works about the same. I believe it's because these are rotated. Are these rotated? Start rotation's 90. Am I randomizing rotation anywhere? I'm giving it rotation over lifetime. Yeah, it kind of shows better here. So I'm moving the pivot to the left, moving the pivot to the right of each of these individual spheres. Now, if I set this to facing, this is a super useful thing. I'm going to show you, I'm going to give you a different particle system here to look at though. And let's get a cube up in here again. This is great. Okay, let's turn this one off. Let's make a new particle system. Parented, let's give it no speed, 1 second duration, 1 second lifetime, emit 1. Okay, so all these particles are emitting in the dead center of my cube here. I can't see them. So what am I supposed to do? So what you can do is you can go into your renderer and you can set these to facing. And that means they're always facing the camera just like a billboard, but the pivot changes. So I can say, bring that pivot a little closer to my camera. So this is going to bias this particle towards the camera. So I can see that particle because it is physically being pulled closer to my camera. This is great for like a glowy effect on the inside of a character or anything like that, that I do need to see a flash that might get, obscured by a mesh in front of it. But I can bias it towards the camera so that it will physically pull itself closer to wherever my camera is looking so I can always see it. I use this all the time. Very useful stuff. And then we've got the custom vertex streams, which that is the custom data, which I will show you later. Probably not in this video because this one's already nice and long. Cast shadows. Obviously, it allows your particle to cast shadows. Simple enough. I believe your material might also need to be set to cast shadows. But I don't know, this plane's not receiving shadows. This project is very bare bones, so I don't really know what's going on in here. But yes, if you want your particles to individually cast shadows, you would turn this on. And then yeah, we went through sorting layers already, so I think we are pretty much through the most important features of a particle system that I use like day to day as a VFX artist. I think that about covers it. Okay, that is where I'm going to leave it on this video. This is like an hour and 15 minutes already. I'm good on that, and I'm sure you are too. I really wanted to talk about more things, but that's just going to have to be future videos. I hope you got some insight out of how to get the particle system to do what you want it to do, because that's what the basics of doing the VFX work is. You have to understand the tools and know how to get it to do what you want it to do. In the future, I would like to talk about using meshes in VFX and UVing them in specific ways to work with VFX, and also probably next I'm going to get into shaders and how you can really elevate your particle systems using custom shaders. I am really looking forward to working on some like actual effects stuff with shaders and showing you what shaders can do, and making some actual test case effects for you to follow along with. That's the stuff that's going to be a lot more fun, but I really had to just lay the groundwork here first so you could understand the particle system, because that really is the basics of VFX, and I hope you learned something. Thank you so much for watching. Feel free to like, subscribe to the YouTube stuff, show this to your mom, show this to your dad, get them into VFX. We need more VFX artists in the industry, so yeah, I'll see your mom and dad soon. I'll catch you next time.